Okay, so we're going to talk about from atoms to compounds. So why do atoms combine? Atoms combine because of something called the octet rule. The goal of every atom is to have a full outer shell. For the atoms at the top of the periodic table, that would be only 2 electrons in the outer shell. But for the ones towards the bottom of the periodic table, or actually after row 2 and beyond, that's going to be 8. So that's why it's called the octet rule, is because most atoms are going to need 8 in order to be full. Now, remember that we had the Lewis dot structure, and the Lewis dot structure helps us determine how the atoms are going to bond. So remember, valence electrons are the only ones that are involved in actual chemical bonding. So Lewis dot structure shows us a picture of the different chemical or valence electrons for each chemical. So if you notice that we have a dot here for hydrogen, it needs to slide in somehow, just like a puzzle piece, that 1 electron. Here, the second one you notice is carbon, and carbon has 4, so it's got 4 electrons to offer for an actual bond. And then if you look at water, you can see that oxygen has 8 electrons surrounding it. Both of the hydrogens have 2. Each hydrogen has donated 1 electron to this octet, and the oxygen has donated 6. So this is basically why we have to be very careful when we do the Lewis dot structures, because the puzzle pieces fit together and help us see how atoms will combine. All right. Atoms will either bond ionically or covalently. Ionically is when electrons are lost or gained. That is a bond between a metal and a non-metal. And covalents are when electrons are shared, and those are bonds just between non-metals, 2 non-metals, or 2 or more non-metals. So if you have a metal and a non-metal, which is what we'll talk about first, you have an ionic bond. If you have only non-metals involved in your compound, then you likely have a covalent bond. Okay, so again, we talked about ionic bonds are formed when electrons are lost or shared, are lost or gained, and that gives it either the positive or the negative charge. And if you remember, the positive one is when we lost electrons, and then we have a cation, and those are our metals, and the negative one is when we've gained electrons, and those are anions, and those are our non-metals. Now the bond occurs because once they have lost or gained these electrons, you have this opposite charge. And you've heard the whole opposites attract. So, the positive and the negative, the electromagnetism of those 2 opposite charges hold it together, kind of like magnets. Remember that, just to review, atoms are electrically neutral. Ion is what we call it when they have a charge. They've lost or gained electrons. Also, remember that only electrons move. The protons cannot change. The proton is the identity of the atom, and it does not change. Again, an anion is a negative ion. It has gained electrons, and these are non-metals. And we write that as a superscript. So we write that at the top. Now, once it becomes an anion, it's no longer fluorine or oxygen. It's now fluoride or oxide. So that gives it the IDE, lets us know that this is no longer an atom that we're talking about. This is the ion, and specifically this is the anion, the negative one. The cation is the positive one. This one has lost electrons. So going back to the one before, the anion has gained electrons, and this cation has lost electrons. So that means there's more protons than electrons, and these are our metals, okay? And again, they're also written as a subscript here, or a superscript here, but we don't change the name for these. It still is just potassium or calcium. Now, we're going to talk about what happens based on where they are on the periodic table. The first group here, that's the alkali metals plus hydrogen, this group all has 1 electron in their outer shell. Now, the goal is to have a full outer shell. In order for these to actually have a full shell, they would have to gain 7 more electrons, and that's very difficult to do. However, if they lost the single electron that they have in its outer shell, then the shell underneath is full. So these atoms will actually lose one electron, forming positive ions or cations with a +1 charge. And this is how we would write this. Second group are the alkaline metals. Same concept. They have 2 electrons in their outer shell, and they could either lose those 2 or they could gain 6 more. That's going to be very difficult to do, so they are going to lose those 2 electrons. Remember, the ease in which they make bonds, meaning if they have to lose 1 electron versus losing 4 electrons, makes them more reactive, and that's why these are more reactive over here. It's very easy to lose that 1 electron. All right, now we skip the transition metals because those have 1, 2, 3, and occasionally 4, mostly 2 and 3, and they don't follow any specific pattern. So I've posted in your Google Classroom in the materials a periodic table with charges, and that will actually, the charges for these will actually be written in the box with the specific elements, so you can look those up. You do not have to memorize those. They're very difficult, and there's lots of oxidation for each one. All right, so then we look at the ones in boron. Okay, these have 3 electrons, so more than likely they're going to lose these 3 electrons, and they're going to still be cations. Again, these are still metals, and remember our metals are all cations. When we get to 4, they have 4 electrons in their outer shell. So they could gain 4, they could lose 4, but more than likely they're going to share. These are non-metals, and they tend to form covalent bonds over ionic bonds. So this is going to be a ±4. So it's not necessarily going to gain or lose. Then we move over to nitrogen, and this group has got 5, so it's going to be easier for them to gain 3. However, nitrogen and phosphorus are often known to share as well, to bond covalently. They become nitride and phosphide and arsenide. Okay. Then we move to the next group. This is the oxygen group, and they need 2, so they're going to gain 2 electrons. They're going to be anions, and they're going to become oxide, sulfide, and selenide. So we have cations from here to here, and then we're going to have anions on this end, starting with nitrogen, oxygen, and then fluorine will also be anions, and they are going to gain 1 electron. They're in a very powerful position when it comes to bonding because they already have 7, so they just need the 1, and they'll become ides as well: fluoride, chloride, bromide, iodide. The last group, of course, already has a full shell. This is why they are called the noble gases or the inert gases. They do not need to bond. They have everything that they need, and they don't really play well with others. They are definitely stable all by themselves. Okay, so go ahead and fill that chart out on your note sheet so that you will know the columns. And again, you know all of these columns here, and then the transition metals will be on the supplementary material in your Google Classroom. All right, so how do we write these ionic compounds and formulas? All right, so the first one is iron chloride. So I know that chlorine is going to be the anion. Again, iron is going to be a transition metal, so I have to actually look at the periodic table to get this charge. And then chlorine, I know because it's a halogen, I know exactly what that one is. I'm going to see if they're balanced, and this one is 3+, and this one is 1-, so they're not balanced. I do always put the positive one first, cation first, anion second. And so I'm going to have to crisscross these in order to make them fit. So this 3 will come here, and the 1 technically goes here, but we don't write 1s. So this becomes FeCl3. We're also going to do tomorrow some drawings of Lewis dot structures so that we can visually see how that works as well. The next one is aluminum sulfide. I have to look at the periodic table. I don't need the transition metals because they're not transition, but we will have to look at the periodic table. Aluminum is a cation at 3+. Sulfur is an anion at 2-. We do have the plus first and the minus, but 3 and 2 don't balance, so we're also going to have to do the crisscross here. And we're going to say that Al becomes 2, and sulfur becomes 3. So we get Al2S3, okay? And again, aluminum sulfide would be our 2-word name. All right, so the next one is magnesium carbonate. Now, carbonate is a polyatomic ion, which means it's a group of ions that work together as one, okay? So magnesium we know is 2+, and carbonate is CO3, and it together has a charge of 2-. Now, you do not have to memorize these. There will be a list of them that you'll just have to copy off the list. But they cannot be broken up. Carbonate cannot be broken up. It works together as one. All right, the balance is that we have the plus and then the minus, but they actually are balanced because these are both 2s. So once we get that, we can just write MgCO3. Remember this CO3, this 3 is part of that carbonate group, so it does not affect the balance at all. It's just part of this group. All right, so if we name them, just like we talked about, the first one, the cation, just is calcium, right? We don't change the name. But the anion becomes IDE, so it becomes calcium chloride, okay? Now, we talked about the nonmetals. The nonmetals will bond covalently, and that's when electrons are shared. However, they don't share equally because some atoms are actually larger than others. This right here, water, is a very good example of that. It is a polar covalent bond, meaning that oxygen has all the power here because it is a much larger atom. And it causes it to have this bent structure versus a linear structure. So we'll talk about that some more next week. These are just some examples of some things that are bonded covalently. And remember, covalently means that the electrons are shared. Your organic compounds, your life elements, these will bond covalently and not ionically. All right, so that's kind of your overview. Fill out your note sheet. And then also there's a bonding basics companion for today. Most of that information comes from the earlier sections, but just stuff that we need to recall in order to do well in this section. And that is electrons are involved in bonding. Electrons are in the outer shells. Protons and neutrons are found in the center, and things like that. So fill those 2 out. And then tomorrow we'll go through some of the drawings and the actual naming and bonding.